Okay, here we go. So BMS gateways. This is not a new technology, but it's a much more improved technology from what it was a few years ago. We started using gateways to make the transmission of data a little bit better, or a lot better, between BMS and anybody's mechanical system. Essentially, everybody's kind of doing this. When we looked at what we can get with a gateway that we can't get with a regular interface, is we have harmonization between systems. So what the occupants need, what the space needs, what the mechanical equipment needs within the building, whether air handlers or radiators or whatever, that now can communicate back to either the chilled water, the hot water system, or the air makeup system through gateways. I'm going to specifically talk about the Viessmann gateway today, so it'll be about our gateway and our boilers. Goal is to not duplicate work and to add a value to the system, so that we're only producing the energy that we need. We're not producing not enough or too much. We can get better enunciation of alarms and problems, so we can head off things of the past. We can provide historical data with trend logs and things like this. So this is all the value of having a gateway, which overall reduces installation costs. When you look at, if we reduce the duplication of work, we don't have as many sensors, we don't have as many wires, we don't have as many junction boxes, because we're sharing information. The Viessmann gateways, we have two different types of gateways. We have the Vitogate today, which is what we'll talk about. The Vitogate 300 is a backnet or Modbus gateway to our Vitotronic controllers. And we have a whole series of other gateways we call Versatronic. These gateways are built here in Waterloo, and they are gateways that interface with other types of our systems. So we have a quick list here. Some of the older network controllers, OpenTherm, which we use on our Vitodens 100 water solar systems, and we have a couple that are also, GLON or BACnet or Modbus, which are very similar to what we're doing now. They do the same job, kind of in a different way. The Vitogate is an easier to control program if you're on BACnet or Modbus. So when you look at the gateway and what its place is, and what the building controls and what the boiler controls are, we look at heart and brain. The building is the brain. It determines what it needs from the machine, the building envelope, and the people and stuff like that. And the heart is the mechanical equipment. And over the years, technology's changed to the point where it's just not acceptable anymore to turn a boiler on and off from a space temperature, especially in a larger commercial application. We used to see that there was a binary command sent to the boiler to turn it off when the building got warm. Well, that's not good for the equipment. It's not good for the environment. It slows the response time down. So it's not no longer an acceptable technology anymore. We have to understand, though, what the technology we're using so that we can properly decide how to operate. In the boiler world, there are basically two different system type designs, two families of designs. The condensing boilers, which we're seeing all the time now. We see very little non-condensing operations. But non-condensing boilers were the first type, and the condensing boilers, which we see more of now. And you'll see some which are called hybrids, which might have both. That's not quite as often as it used to be. It used to be that even in a complete boiler retrofit, we would sell or have one installed, a higher temperature boiler, because it was only going to operate on the non-condensing days. And part of that was cost, part of that was operational characteristics of a condensing boiler. It didn't like to be really hot. But nowadays, the premix burners on a condensing boiler bring the cost down very, very competitive with a high temperature boiler. So we see less and less. We still see mechanical rooms where they want to stage the retrofit. So they might say, we're going to replace boiler 1 and 2 this year, and then we'll keep boiler 3 and 4, and in the next few years you change them. So we just still see hybrid systems, but generally we are seeing less and less going on. So we got the boiler brand, we got the building. We need to look at who does the best at what things. The BMS system is best at deciding what the building needs. It looks at the building envelope from multiple input sources and says, hey, this is what we need. It comes up with a common point for that. It looks at the occupancy requirements and says there's people, there's no people in the building, so that changes our heat demand. And we then decide what right now at this particular time is the best water or air temperature need for the space. And the boiler plant has its own values as well. It receives the set point from BMS, and it does something with that. It manages all aspects of the boiler plant, all the starts and stops of the boiler equipment, all the modulation points, all the load sharing between multiple boilers. That's all done by the boiler plant controllers. Any associated devices like low water cutoffs or air makeup systems for combustion air, these are all managed through the boiler plant. So we have to kind of keep those two worlds separate if we want to have the most efficient and the most safe operational system. One of the biggest downfalls of mechanical equipment in commercial buildings is less than 50% of commercial equipment is actually commissioned to the factory specification in North America. That means that potentially less than 50% of all mechanical systems are running the way the manufacturer of that equipment decided it should be run. So there are two ways we can kind of integrate the building with the boiler. The way that's been used for years is mechanical connections. There's a limited number of points we can put in or out. We have the databases that the control has only so many binary points or so many analog points, and the same with the building automation system. There's only so much stuff we can connect hardwire to. And what we get then is just on-off status or an analog set point or something like that, or maybe an analog feedback from something, but it's really not a whole lot of data. And that meant that the building automation system duplicated stuff. So we had extra sensors. So it's not uncommon to go into a mechanical room and see two sensors right side by side. And one is the boiler control sensor and one is the building automation's monitoring sensor. And, I've gotten in the systems where you don't know which is which. And the only way you can troubleshoot is you pull the wire off of one to see which system goes into the one. So these are never a good idea, but it was the best way we had for a lot of the years. And now we have the ability to use a gateway with digital communication. We can then communicate with the devices, between the boiler devices and the building automation devices in real time and share data, just like we Google something on the internet. We can instantaneously have information. So like I said, only so many things you can do with a mechanical interface and lots of duplications in sensors and things like that. And there's really no communication between the two. So all you have is the hardwired equipment. The data that you need doesn't translate because there's nowhere to get to it. When we introduce the gateway, we end up with a electronic communication device. The gateway is essentially just a translator. So we have information on the Viessmann LAN bus, which is sharing information between all of our controls so that operate the plant efficiently. And the BMS system looking at the building, and it wants to know what's going on in the Viessmann world. It wants to tell us stuff. It wants to read stuff. So the gateway allows us to do that efficiently. So now we have a translator. So it's no different than somebody speaking German and somebody else speaking English. It's just translating data. But as with everything else in the translation world, there will be occasionally things that just don't have a word. You see that when you listen to the news and they're interviewing somebody that's native languages in English, let's say, and they just say, I don't know what word that is, because there's no word in their language for it. And there will be some points that just don't translate back and forth, and there's very few of those, but just be aware that you can't get 100% of the data you want all the time. So when inside the gateway, there's two sides to this. There's going to be the Viessmann side, which is the Viessmann LAN points. And it's going to be the building automation side. In the case of this particular slide, it's BACnet. And you can see that there are Viessmann addresses and there are BACnet addresses. And what the gateway is doing is translating those. And you can also see that what we have is different tabs, so you can narrow down in some areas what you want to see and what you don't want to see. Now, some of these points are going to be read-only points. Some of them are going to be what we call read-write points. A temperature sensor is something you read. It's not something you send a signal to. You can't override the temperature with, say, well, I don't like that temperature, I'm going to make it something else. But a set point is something you want to write. So you can read the set point, what's in the controller, and you can also write to it to say, I want to change it or make it something else. And so there'll be different variables. And the same thing with binary points. These what we're seeing here is analog points, but there's also binary points. Some binary points are read-only, some binary points are read-write points. So when we look at the gateway itself, There's a few different connectors and stuff. So let's take a quick look at that. The first thing we see is there's a USB port. And the USB port is designed so that you can download or upload databases to the gateway. So when you configure the gateway, when you got it the way you want it in the building, it's always a good idea to upload it. So you can upload it to your computer, but you can also upload it to a flash drive. And if you've got more than one building that's very similar, you have two buildings with two CM2s in them, then you can take that flash drive, upload the file into it, and then you can take it to the other gateway in the new building and download it and make very minor changes to the database. So this takes away the slowness of creating the database. Then we have the LAN connections. That's these two little ports down here, and they are going to be how the Viessmann control talks to the gateway. And you see there's two here because the LAN network is a daisy chain, goes from device to device to device, and we'll take a look at that in a second to show you how that works. You also have the LAN connection, which is the same look connector as the LAN. It's the RJ45 connectors, but this is where some BMS systems will connect to. And if you want to hook up your laptop to this to do the configuration, that's where you're going to hook it up to. We have RS45 connections here, and there's some dip switches above that, which are for configuring those RS45 connections. And that's just a different way. We have the LAN and we have RS45. And which one you use will depend on what the building automation guy has in his system, how he's communicating. And then, of course, we have the power supply. This is a 24-volt DC power supply that we supply with this gateway to give it power. And at the very bottom, you get the screen here, you'll see this little hole in the unit, and there's a little graphic for it there. This is for the reset of the device. It's always a good idea to reset the device after you've updated databases, or if sometimes you have an issue, you've had a communication problem, it's just sometimes faster just to reset the device. There's different levels of reset, which we'll walk through in a couple minutes. And then we have a series of LEDs, and they will tell you what's going on within the controller. You can often just look at the LEDs and see if the communication's working or with data's moving, that kind of thing. The gateway comes standard in this gray box. It's mounted on a little piece of DIN rail in the box. The power supply you can see on the right there. And we see the gateway on the left. And then we have a 120 volt power cord down the bottom down here, which takes it out to just a regular 120 volt receptacle. You can take this gateway out of this box. We see a lot of times it's removed from this enclosure and put right in the boiler panel. There's no problem with doing that. We want you to use the same power supply. We supply this power supply with the gateway because it's a very clean filtered power supply. If you're going to take it out of here, one of the things I usually try to recommend guys do, there's two screws that hold the DIN rail in place. Just loosen those up a little bit, because when the DIN rail is tight, the gateway sits pretty sturdy in there. And if you loosen the DIN rail, it's easier to get the gateway out. If you look at the gateway itself, it has a couple of labels on one side. It has the serial number, which is this 16-digit number you see here, and the barcode, that's the serial number. The model number, and all of its ratings in North America. There's CSA, C, and CSA US ratings for this device. And on the other side is the map of the connectors we just talked about a minute ago. So the lawnmower, like I said, is RJ45 connectors. If you buy the Viessmann lawn cables, they're actually shielded cables. Now, we don't have to have shielded cables to make this work. But if you're in a mechanical room that has lots of RF noise, you got variable frequency drives and things like that that throw a lot of RF. Then sometimes the shielded cable helps. So when you buy the cables from Viessmann, they're shielded, but it's not a requirement. We don't say it has to be shielded. And you see there's two connectors there. So if the gateway was the last device, then you need the end of line termination here. And you can see here how we do that. In this case here, we've got the gateway on one end and then 8 boilers, the cascade being boiler number 1. And then we have the end of line termination at the other end. It doesn't matter what order these things are in. The gateway can be in the middle, it can be in the other end. As long as it's a daisy chain, and at the end of the line at each side, we have the end of line termination. And every boiler then is going to have a lawn card like we see in the center of the picture there. Now on the BMS side, on the sorry, I got to clear my throat here. We're using BACnet IP or Modbus TCP IP. We're going to connect it through this other RJ45 connector, which is, again, standard LAN cable or network cable. This connector actually has a couple of LEDs built into it, so we can see communication happening on the bus. They're just, information. They really don't tell you much. They're just showing you that the thing's talking. But just standard cable. These are not crossover cables, and a lot of the older gateways you had to use a crossover cable to talk to these things, which meant that the pairs on each end were switched over so that it didn't need a hub in the middle. Well, these are all now they don't need crossover cables. So when you look at the big system, now you have the long system down the bottom, and I show 5 different configurations. We have our current boiler line and even our older Viessmann cast iron or first generation condensing boilers. As long as they have Vitotronic controls, you have an older system that's got decomatic controls or trimatic controls. They're not going to be able to talk in the gateway because they don't have that ability. We do have some retrofit possibilities. So if you have an older mechanical room, you want to tie it into the system, call tech support and talk to them about if there's a retrofit kit. If you're at Decomatic, there'll be a retrofit kit, and if you're on some of the older stuff, it may be or may not be available. So beyond the lawn system, we have the Modbus or the backnet system, and so we have the gateway which communicates to that. And there could be other manufacturers on that side too through their own gateway. And what happens is then to the workstation, they get information, and the Bms guys will make pretty pictures and nice graphics so that it's easy to read. And that it gives you lots of bells and whistles. But the heart of it is all the points in behind. And what they do with the database, they can take the points we have and they can create background loops and algorithms that they can allow them to monitor things and trend things and that kind of stuff. So then there's a power connector. The gateway actually can be powered from 24 volts AC or DC. It's better if you use the DC power supply we give you because it takes all the ripples out of it. It's a nice filtered power supply, 1.4 amp capacity on it. And then we have their RS-45, and these are as communication. They're just wired into terminals. There's no connector on it like there is with the RJ-45. And beside that, there's a set of dip switches, which we use for the configuration. So again, like a daisy chain, just like the lawn side, it's just device to device to device. This is the backnet wiring to it, and if you did MSTP, we have MSTP. It's just a daisy chain. Again, if this is the last device in the group, you're going to have an end of line termination at switch 3 there, which you're going to turn on, and rather than a dongle, it's just a toggle switch. In the Modbus world, MSTP. Again, it's the same type of wiring. They lay it out a little differently, but it's the same. It's communication. So the 2 dip switches on the right, 1 and 2 here, they are used for solving communication problems. They're designated really for what they call long or short runs. If your cables are really long on the Modbus side or the backnet side, or they're really short, then you can use these dip switches. But ultimately, it's not just about cable length. If you're having troubles with communication, set the dip switches in a couple of different ways until you kind of clean it up, because there's a few things that the dip switches actually help with. Cable length and baud speed. Baud speed is how fast it communicates. The older systems will have a lower baud speed than a newer system typically. But there's also a thing called rise time, or the active or tri-state modes. And rise time is the amount of time it takes for the device that's just going to start communicating, go from a 0 standby voltage to its active working voltage so that it can get the data packs out. And if the device isn't communicating for a long period of time, it goes into what's called tri-state mode, and it doesn't have any voltage on the bus. So there's occasionally times when what will happen is it want to communicate, but it's starting to send the package before it actually gets to its full state, so some of the data is not clean. When you set the dip switches here, it'll put some bias voltage on that bus, and so it keeps a minimum voltage there or a maximum voltage there, so that there's always some noise on the bus, so that it's not going to take the same rise time. And we're talking milliseconds here. We're not talking huge amounts of time. And again, we also have the dip switch for end of line termination for Modbus as well. Now there's 4 pilot lights, 4 LEDs. The power light, which is green, tells you that the device has got its 24 volt power. We have transmission lights from the building automation system. They're going to blink just like, flashy blinky lights like you see on a modem or something like that. The one that's really is good to have is this one here, the multicolor, because it'll tell you what the status of the gateway is. If it's solid green, it usually means somebody's pushed the reset button and it's getting ready to reboot. If it's flashing green, that's a normal operation. The gateway's talking to the BMS system and the communication, lines of communication are open. If it's flashing red, green, this is what we call a Dcp server. So if I want to talk to the gateway with my laptop, that's one of the ways I can do it. And we'll go into a little bit more detail in a sec. If it's illuminated orange, after it's gone green solid, it'll go orange to show you that it's rebooting. And if it flashes orange, we can see that it's rebooted, but there's nothing in it. So a brand new gateway will show up like that, as there's no database in it. Flashing red will give you an indication that there's a problem on the communication bus, so you can start looking for communication errors. And illuminate solid red is what you're going to get while the database is loading. So once you're putting a flash drive or something like that into it, when you're loading it, it'll be a solid red color while it's doing it. Again, the USB port is for flash drive, so you can download or upload databases. The reset button, you see that little tool on the top corner here of the slide. This little tool comes with the gateway. Now, if you've lost that little tool, you can find a paper clip. It'll work just as fine. Something pointing like that. And then we can do various levels of reset here. So we'll start with the big one. If you push that reset button and hold it for more than 15 seconds, the complete reboot and reset of this gateway. So it'll wipe the database that's in it. It'll take away the IP address that you had put in it. It'll take away its name. It'll basically go back to the way it came out of the box from the factory. And sometimes that's a thing you want to do if you've got a really corrupted database. Somebody's been messing around with it. You don't know what's going on. Sometimes it's just faster to do that. And again, the value of having your USB flash drive with the database on it that you saved originally is you can just download that thing. When you hit the reset button for just a couple seconds, it will restart the gateway. And again, a lot of times what happens is you've got a problem on the bus, the BMS system is gone glitchy, or the launch side's gone glitchy. It just rebooted. Basically, if you hit it for a couple seconds, let go, the database remains. It just reboots the thing. So it's like a computer. Did you see the blue screen of death? Sometimes you just want to reboot. Now, there are two methods of getting into communication with this gateway after it's been configured. So you're going to configure the way the BMS guy wants it, and now you want to hook up your laptop to do some changes. If you hold the button for 5 seconds, but less than 10, it goes into what's called static IP. So your static IP on the gateway is 169.125.4.0.1, and you're going to have to set your laptop as a static IP and give it a number in the same network. If you're like we are here at Viessmann, where the IT department controls what you can do with your computer, you may not be able to set the IP manually. So the gateway also has what they call a Dcp server. So it'll actually assign an IP. So no different than hooking up your computer to the internet. So you hold the button for a little bit longer for that. And what happens is the gateway, when you hook your computer to it, will go and say, here's your new address. And once you've had the address, then you can communicate. Either way works fine. I like to do this, the fixed address, because it's just a little quicker for me, but it doesn't matter either. So when we're doing a static address, the gateway's address is going to be 169.254.0.1. So your laptop has to be something higher than that, between 2 and 255, essentially. The other thing to look for is the subnet mask, because most computers will default at 255, 255, 255.0, and you need 255, 255.0.0, or you won't be able to communicate with the gateway. And if there's other files in there, like other information on like the standard gateway, you can just leave that blank. So now that we got the configuration right, we're going to hook our laptop to it. We got our IP set. We're going to need to talk to the gateway. So you open up any web browser. It works with Chrome. It works with Firefox. It works with the Internet Explorer. And once you've got your web browser open, you type the URL into the URL line. You type 169.254.0.1. Make sure you put the decimals in there, and you should get a page that looks like the one that's in front of you. After that, you'll be able to log in. But before we get to that point, up in the corner here, there's some information. So when you look at the gateway, somewhere that lost. I lost that slide. Okay. Well, up in the corner here, there's some information on language and help menus. These are for the gateway itself, not for the database. I'll get into that one in a couple minutes. So your login default is Vitogate is the username, and Viessmann is the password, all lowercase. These are not normally changed. I don't know of any configurations that we've sold out that they changed it. If you change it, you need to remember what it is, because the only way to fix it, if you forget, is to reset it to factory default. And again, maybe that's why you have a backup on the flash drive. So under once you log in, you'll see a bunch of tabs, and on the first tab is general. But right again in the top corner, we see more information than we saw before the login, because now we have the help, which you can also get from the help tab, but there's also a log out, so you can log out of the gateway. And a little bit more detail here on the languages: German English, North American English, UK English, and French. What's the difference between UK English and North American English? Mostly terminology. In Britain, they keep their hot water in cylinders, and we keep ours in tanks. They talk about flow sensor, which is actually a temperature sensor. We get confused with that, so we call it a supply temperature sensor or something like that. Then you see this little double arrow thing. In this menu here, that is to refresh the screen. You'll see that same icon in different places in the database, and what they are there is to select or deselect things. So your next screen is where you put in what you want to call this gateway. This is totally up to you what you call it. It doesn't matter what it is, but you'll see a tab here, which is important. You have to select whether you want BACnet or Modbus. If you don't pick the right one, the database is generated in the other form. And the language is also important. The gateway is in English if you pick English in the home screen, but the database will translate from long to BACnet or Modbus in whatever language it's set here. So you might get all German points if you didn't change it. And then you see the metric units or imperial units down the bottom. So on the next page is the IP network. This information you have to get from the building automation guy, from your integrator. He has to tell you what he wants it to be. This is the network that he has to talk to the gateway on. So this information comes from him. System time, you see the default here is using the LON time. This is what I recommend, because when you use the LON time, any alarm points that are generated in LON, that time base will continue through the gateway, so it'll actually show the right time based on the LON control. You can change it to other things, but then you might have to chase your time frame a little bit if you're in around daylight savings or whatever you're going to do. Backup and restore. So I have a database and I want to back it up. We can plug a flash drive into there. We can back it up to the computer or to the USB drive, and we can restore a file. So we want to put a new file or replace the file that's in the gateway. We click restore and then we click start, and then it'll download or upload that file. The file, again, it's always a good idea to do a backup when you're done with the gateway, because that way you have the current working database. It'll connect or collect all the information, including the device information, like whether it's BACnet or Mod. It'll collect all the data points that were mapped. It'll collect the IP address that the building automation guy told you to put into it, and all that kind of stuff. And if you're doing trending logs, it'll actually collect that data as well. The file that it creates is called it'll have a file name with a .tgz on it. This is actually a compressed file in the Linux system. The operating system on the gateway is Linux. So it's not an easy file that you can manipulate in the Windows or the Mac world. And there really isn't any reason to do that, because if you unpack this in the LON or in the Microsoft world, what you'd see is machine code. It doesn't make a lot of sense. So it's just a compressed file that we use for gateway. There you can change your password. Again, don't recommend you do that unless you're really good at remembering stuff. Then there's the update screen. And when it's at the top of the screen, there's the current configuration that's in the gateway. That's the software version that's in the gateway right now. Now, you can change that, but there isn't a lot of reason to change it. If there's product enhancements, correcting bugs, something like that, you're looking for data points that didn't exist in the older system but do in the newer system. When we introduce a new Vitogate controller, these are all reasons why you might want to update the gateway. But generally, whatever gateway software you have in there, if it's working, you don't have to worry about it. Don't update it just because there's an update available. The current version is 2.1.2.0, and I'm not even sure if the gateways that we would be shipping today actually have that version in, like the 2.1.1.0 still, and it doesn't matter. One of the things that's important is that a new version may not have all the points that the old version has, because if we add a point, we might remove a point in the database because it's not used anymore, and the controller you have might want that point. So again, not really a good idea to update it unless you're having problems. And then you would find the browse file, you'd find it on your laptop. You have to do it from a laptop in this case, and the file name is going to be update.ugw, and you're going to download that. You're going to push the start button, and then after it's all done, you're going to reset the gateway. If you do not reset the gateway, it will not do anything, right? So you can do a complete system restart, like you see here, or in which keeps the data loggers, or you can delete the data logger as well. Again, you're going to hit restart here. So you're going to give this little screen like this, and then it's going to reboot. The whole device will shut down and reboot up again. So you're going to have to log into it again when you've done that. Now, when you can set up the LAN tab now, this is the Viessmann world of the controllers. So LAN is a communication protocol we use within our Vitogate controllers. And we have subnet system, we have node, and normally the subnet system stays at 1. If you had 2 gateways in this, say 2 mechanical rooms, so you have 2 gateways talking the same BMS system, you'd have to address one to something else. You have a system 1 and system 2 that just keeps the database separate. The node address, which is the LAN participant number, is 97 by default. We don't have any controls other than the gateway to do 97, so usually you can leave that where it is. It's a good idea, though, when you hook up the gateway to the LAN side, you have to go to whatever the data point manager in the LAN system, usually that's the cascade control, and do a participant check on that control to make sure it sees the gateway. So it'll come up in the list as participant number 97. So that way you know that the communication between the gateway and the LAN system is working, the Vitogate controls is working. And then you're going to do a scan participants. And once you scan participants here, you'll get a list of all the participants that are here, and you'll get them lined up in a list here as well. And when you click on it, and you'll be able to get into the points of that list. Now you'll see that this number here, this name here, may not line up. It won't say Vitogate 200, or it won't say GW6B. Different controls in different modes will show up differently. So a GW6B control on a CM2 will show up as a GW2B in a standalone control, and a GC1B in a slave control, or as an MW series controller as a cascade. So depending on what software in the control we're using, whether it's a cascade or a slave, those numbers will be different. So just as the easiest way to track it is, the participant number. You see participant 1, 2, 3, 4, 5, and you can kind of figure it out from that. So this simulator only had 1 control on it, so you can see there's a GW2B controller there. And when I click on it, I'm going to get the database for that controller. And again, we have all the tabs we saw earlier, and there's that little refresh button again. When we click that, it will unselect all the points or select all the points. You probably don't want all the points. The gateway will have about 1,600 points, and this control won't have 1,600, but it'll be a lot of points you don't really care about. Be points for hardware that don't exist. So really what I normally do is unselect them using that little button, and then go through the list and just pick the ones you want. Just click them one at a time until you see the ones you want. So you say, well, I want that temperature, and I want the domestic set point, They don't have any mixing valves, so we won't collect those. And you just basically go through the database and pick the ones you want. And to make it a little bit simpler, you can actually go tab by tab. So if you want to just do the DHW ones, or the boiler ones, or the heating circuit ones, you can kind of do that. So unselect everything and then go through the database and pick what you want, system alarms or other system messages, and you pick whichever ones you want. It's important that whatever you click here transmits to the backnet side, but not everything you see is an actual viable point. Like I said, the controllers are similar controllers, but in the Vitogate 200 as an example, in the CM2, we have the same data points, but the CM2 has a feature in the burner control that checks the status of the gas valve during startup, what's called leak test. The Vitogate doesn't have that. So you can have the point, but there won't be any valuable data from it because it won't have anything to look for. It's important that before you leave a page, you press save. You need to save the database before you leave it, or it will not keep it. So if I just clicked all those points and then clicked a different tab, when I come back, it won't have done anything. You have to click save at every page that you're working. Just a little bit of note on alarms. Alarm state is what you really want to map. Alarm state basically mirrors these alarms in the controller. So you get, it'll be reset when the controller resets, that alarm will disappear. So you can see that information only when it's active. And they have 10 alarm states. So 1 to 10 is the oldest to newest. And if there's 11, it'll just overwrite the oldest one, the same way it does inside the Vitogate control. So when you click on the first one, it'll actually highlight all of the alarm states. So you don't have to click all those individually. It'll say, do you want them all or nothing, really? Now, when you look in the BMS side, and this is just a screenshot from somewhere, I don't know where this came from, but you can see this is what the BMS guy says. So it's alarm state 1, alarm state 2, the points they mapped. And I can see that 18 lead break outside temperature, and this is the gas valve alarm. This is what you're going to see on the BMS side. So you're going to see basically the same thing you see in the Vitogate control. The OK beside this isn't saying that the alarm is okay. This is reporting to you that the communication to that point is okay, that the point is communicating properly. So in the normal state or an alarm state, it's okay. If there was a problem with it, couldn't read that point for some reason, the database was noise on it or something, then you wouldn't see okay. Now you can map other alarm points, but just be selective how you do that, because these points here, these are directly, you can see this one default flow sensor or 20 short circuit temp. If that fault comes up, it'll show up in the alarm state too as well, almost like this. But with these ones here, because they're binary points, you're going to have to clear those on the BMS side to get rid of them. Now in the BACnet world, we've mapped all the LAN points, we've saved our database, and now we're going to look at what we do at the LAN side. So there's 2 different ways to configure LAN, BACnet IP and MSTP, and you can see that the data, what we're looking for is different between these 2. This information comes from the BMS guy. He has to tell you what he wants these to be. Device information, you can give it a name, so he can say that, well, this is the Vitogate in boiler room 2 or whatever. You can kind of customize those names as you go. It's going to have just a default name. Doesn't matter what they are. It's just for simplification of finding it. And then the object list. This list here will be the same as your LAN list. If you didn't check a point in the LAN side, it won't show up here. If you did check a point in the LAN side, it will show up here. Again, you see tabs in this side as well. These are based on the LAN or the BACnet side of the world. You're reading the address, you have what it is. It's an AI type, or you got analog inputs, analog variable, binary inputs, binary variables, multi-state inputs, multi-state variables. And you can see that the variable means typically it's a read-write, and the non-variable typically means it's a write. That's a read-only point. It's the same with binary outputs. You'll see that kind of information. So you have the point, and then you have the LAN address. So in this case, it's 1. And you have the point number, which in this case is 001, but the example we show you says 17. And in the pad, the box beside that, you'll see again, you'll have system LAN number 1. This would be, when we looked at that 1 in 97, that's what the 1 is. And 97 would be the LAN address. But in this case here, we're not looking at the gateway. we're looking at that Vitronic controller, which happens to be address 1. Again, you won't see it if you didn't click it in the lawn side. You have a couple little buttons here. The first one allows you to customize the name. So again, temperature sensor 2 system maybe doesn't help, but you might say common supply sensor boiler 2, you know, this kind of thing, to make it clear for the BMS guy. Then the other side is the trending, and you can again give the trend a name. You can say what that trend is actually doing, trending outdoor temperature, or whatever it is. All the data for the trending is going to be set on his side. Once they've set it, you should be able to see how often they're trending it. But this is just so that he can find it in the database easy for what he wants. Again, EDE object file. This is going to be just the backnet points. Again, it's a zipped file, TGZ file, and it's going to back up the backnet line. In Modbus, it's very similar. We have to give it some information about where we are, whether we're doing TCP, RS-45, and the settings for those things. You're going to have to get this from the BMS guide. And then you have a points list, which will look different than the Modbus or the backnet list because it's a different system. So the different language, different way of doing things, but very similar in application. You know, everything has a register, everything has a, you know, CO, ST, INHO. And if you're working in Modbus, you'll know this. If you're working in backnet, you'll know the backnet nomenclature. So you really don't have to know a lot about this if you're just the guy who's from, you know, commissioning the gateways from the BMS guy can see it. But again, if you didn't click it in the lawn side, you won't see it in the Modbus side. Now, there's also a help button. And the help button, this gateway has a built-in help menu. So it's an online help menu. When you click on it, it basically opens up a new tab, like a web page with a PDF document in it. Control plus F, you allow to search it for words. So if you're looking for specific information on the help, and it's a pretty good help menu, and it's inside the gateway, so you don't have to worry about somebody losing it. There's also a way to get it outside the gateway. So from the Canadian or US website, and the Canadian website, it's under the Pro Toolbox. On the US website, it's under Pro Resources rather. And the gateway manual will be in there as well. And there's other places as well. You can get it online from the Viessmann websites. You can also get some more information on the points list from www.vitogate.info. And down the bottom here, I've listed a few things that are helpful for maybe just understanding a little bit more about BACnet or Modbus. These are not Viessmann documents. These are documents written by BACnet or Modbus to give you a little bit more information on how they do things. Most of these documents I'm going to give you if you attended today, you're going to get an email with a PDF of this presentation. You're also going to get all of these documents too, as many as I had on hand. Some of the ones you're going to get are the documentation. So this is the supplementary document. This basically walks through how LAN or BACnet points go through the system. The LAN talk or Vito talk. This is the document was produced by a gentleman who used to work for us in the controls. So you guys probably know Jeff Cox. He wrote all these Vito talk documents over the years. And this particular one I'm going to say has specifically about BMS systems and about LAN. So it's a good, easy to read. It talks about snippets and univets and all the things in the LAN world. And then again, a hard or a PDF copy of the current manual. So ultimately, the gateway means you're going to have to communicate. You're going to have to talk to the engineer, the building integrator, the building owner to find out what they need. Before you can build the database, you have to know what they want. What do they want out of the Vitogate? What do they want to read? What do they want to write? And you need to know the communication settings. No sense starting this until you have some of this information because you're going to be going back and doing it again. So it's a good time to sit down with the integrator and say, okay, we have a Vitogate, and we can give them some guidelines on what points are available and that kind of stuff. We have some spreadsheets that we've developed for those things, and you can get those through the commercial department to give you some information on that. Remember, not every point in the LAN world can be mapped to the gateway. Not everything has a direct translation. And remember, save your changes before you leave the page. Remember, restart the gateway when you're done. You have to restart the gateway or it won't see everything you did. We have a lot of tech calls where, oh, map the database, but the guy doesn't see it on the other side. Well, you need to restart the gateway so it can write that information to the system. There is an online simulator. I don't have the URL for this right here, but there is a little toy online you can play with. If you guys send me an email, I'll find it and email it to you. But you know, it is an online simulator. It's based on the European network controller, so it's not exactly the same as us, but you can kind of get an idea how it works. It's just as easy to get a gateway to play with. So if you've got a gateway you're going to install somewhere, hook up your laptop, hook up the control to it, and just play with it. That's really the best way to learn how to do it. Now, before we go, that's the last of the slides I have. Before we go, I have one more slide for you. This is the CIPH conference that's happening next September. As far as I know, this is the only planned live, webinar or a trade show that I know of. Everybody else is still thinking it's virtual. I guess CIPH is open by next September. We'll be over the hump of this COVID thing. But keep the date. And if you want to go to that, it's in Saskatoon. Saskatoon's not a bad place. I've been there. It's nice. So you can enjoy a little vacation in the flat province and take in the trade show. And if you have any more questions, just send them in, and we'll deal with those. You can also talk to our commercial department. They are a great resource for helping you out with these things. And we're actually going to do some one-on-one training with some of those guys and give them a little bit more insight as well. So we're all ready to help you guys out. And enjoy building automation networking.